We are the actual android population in the known universe. Imagine that we're the most important location for information. Cosmologists work within this unending framework. Generally, everywhere in the world, people remain awestruck by this constantly accelerating discovery. The journey through James Webb Space Telescope is now barely noticeable. City Light's focus is an unfathomable 7 billion miles away from Earth, surpassing all questions. This remarkable accomplishment does more than just increase our perspectives regarding who we are. Awareness of the universe and theories go wild as researchers examine the data, looking for indications that could unlock the secrets of these perplexing, amazing ideas. Make sure that we are following the lead of a few remarkable individuals in the universe. The universe is overflowing with development and life, extremely beyond our capabilities to determine. Is it possible that these distant lights indicate the presence of extraterrestrial societies? What is the significance of this for our understanding of the probability of universe-wide life? Join us as we explore beyond Earth and what the James Webb Telescope recently observed. City lights, sent 7 trillion miles away on Christmas Day 2021, are now off into space. The goal of the James Webb Space Telescope was to surpass the highly regarded Hubble telescope, which is amazing at capturing sharp images of brilliant new objects, global frameworks, and more. The unmistakable goal of the JWST is to concentrate on the movement of the first universes by looking into distant horizons. Universe residents who live nearby make sense of this journey. The duration of light in our universe spans millions of years. When the telescope gathers light, it catches these things unchanged for billions of years. Space experts measure distances in the past. The best unit is light years, the distance that light travels in a single year. One of the most memorable efforts of the mission was a huge picture of the field presented by the U.S. on July 11, 2022. Joseph Biden, president at the time, addressed the nation from the White House. The Hubble Space Telescope concentrated on a single area of the sky for 10 consecutive days, beginning on December 18, 1995. This led to the discovery of the Hubble Deep Field. The region had very little prominence, a small spot accounting for about 1/millionth of the entire sky. However, 3,000 new objects were recently discovered. The gigantic systems tracked by Hubble span billions of years and light-years away. With an emphasis on SMX 0723, the first deep field galaxy group was likewise found in an insignificant sky district. The design of galaxy SMX 0723 is 4.6 billion light-years away. Further away, the galaxies behind it are amplified by an intense gravitational field. The brilliant system's foundation is twisted into massive curves where gravity is most extreme. In one instance, it was established that a star's light took 13.1 billion years to reach the telescope. As a result, the light's passage through space extends as far as the universe expands. The primary goal of JWST has been to observe light from the void of their stars. Stargazers have clearly seen JWST's pictures of areas lit by galaxies previously discovered by Hubble and other telescopes. By collecting information at those frequencies, JWST allows us to see how galaxies have evolved over time and formed the structures we observe today. Unlike previous telescopes that took days or even weeks, JWST captures the deep field image in just a few hours. No matter where it looks, it inevitably locates galaxy clusters in the universe. However, galaxies are not the only things that serve as enhancement points. Experts have used JWST to take images of certain galaxies, such as VV1191, to study how one galaxy's light changes as it passes through another. The results of this study will reveal the properties of intervening galaxies. Additionally, evolution suggests that JWST might have made an exceptional discovery, an incredibly distant galaxy announcing the possibility of auroras on an exoplanet. This discovery was announced on the official website. The absence of a host star and the low temperature of the exoplanet make it difficult to determine where its upper atmosphere's energy originates. However, the presence of auroras suggests methane production, similar to Earth's auroras. On Earth, auroras occur when charged particles from the Sun interact with the planet's magnetic field, producing a spectacular light show near the poles. Jupiter and Saturn have also created auroras due to solar wind interactions. However, W1935, a bizarre celestial object, lacks an orbiting star, making its auroras a huge mystery. Proxima Centauri remains a subject of intense study. The exoplanet TRAPPIST-1, located approximately 4.4 light-years away in the Milky Way galaxy, has shown signs of water, raising the possibility of extraterrestrial life. When will we finally see the earliest evidence of life beyond Earth? Recently, astronomers observed an enormous black hole, significantly larger than our Sun. This black hole, discovered across various frequency ranges, is consuming everything around it. It is 40 million times larger than the Sun. What significance does JWST have for us? The telescope has revealed that this massive black hole has existed since the early universe. Likely, nothing else in the universe moves quite like it. This cosmic monster devours everything in its vicinity at an astonishing rate. Dr. Lucas Fu and Professor Alistair Z. Bungwan from the Israel College led this discovery. According to their findings, this enormous black hole is nearly 10 times as massive as previously estimated, making it an even more formidable object. Fortunately, it was found around 129 billion light-years from Earth. Even farther away, it continues to get closer to the limits of our understanding. The implications of such discoveries are profound. Scientists now speculate that supermassive black holes may have formed much earlier than previously believed, challenging existing models of cosmic evolution. If this hypothesis holds, it could redefine our understanding of how galaxies and their central black holes co-evolve. Meanwhile, astronomers using JWST continue their search for exoplanets with conditions suitable for life. Recently, they detected atmospheric signatures on a planet orbiting within the habitable zone of a distant star. The presence of carbon dioxide, methane, and even potential traces of water vapor suggests a complex atmospheric composition. Could this be the first sign of a world that harbors life? Researchers remain cautious, as natural processes can sometimes mimic biological activity. However, follow-up observations may confirm whether these signals are truly indicative of life beyond Earth. Beyond exoplanets, JWST has provided an unprecedented view of the early universe. By capturing infrared light that has traveled for over 13 billion years, the telescope allows us to see galaxies as they were just a few 100 million years after the Big Bang. These ancient galaxies appear smaller, denser, and more irregular than modern ones, hinting at the chaotic processes that shaped the cosmos in its infancy. One of JWST's most striking images revealed a cluster of galaxies warping the fabric of space itself. This gravitational lensing effect magnifies distant objects, allowing scientists to observe even fainter and more distant galaxies than ever before. Such observations could ultimately help resolve one of the biggest mysteries in cosmology, the nature of dark matter. Dark matter, an invisible substance that makes up most of the universe's mass, can only be detected through its gravitational influence. JWST's precise imaging of gravitational lensing events may provide crucial insights into the distribution and behavior of this elusive material. As JWST continues its mission, astronomers eagerly anticipate more groundbreaking discoveries. From probing the atmospheres of exoplanets to uncovering the secrets of the early universe, this telescope is revolutionizing our understanding of the cosmos. Each new image and dataset brings us one step closer to answering some of humanity's most profound questions. Are we alone in the universe? How did the first galaxies form? What lies beyond the observable universe? The journey of cosmic exploration is far from over. With every new discovery, JWST reaffirms the boundless curiosity and ingenuity that drive scientific progress. The telescope stands as a testament to human ambition, a window into the vast and mysterious expanse that surrounds us. As the universe unfolds before our eyes, we are reminded of our place in this grand cosmic story, small yet significant, searching for knowledge in the infinite depths of space. A black hole that consumes everything in its path is rapidly changing, as indicated by the red shift when the JSST began sending back its confidential information. As they sorted through the data, analysts were exuberant. They discovered 3 small objects in the program with a weak red glint. These objects caught their attention. They believed right away that a large black hole was nearby. When they examined the data and used gravitational lensing, they discovered something substantially more intriguing. The realization that similar phenomena exist in other supermassive black holes from the early universe has provided fresh perspectives on the movement of black holes as well as their host galaxies. This connection is still largely unknown, but it could point to the early stages of massive objects' evolution, such as the materials that formed stars and fell into space. Scientists cannot yet observe black holes directly to see precisely what is happening. However, when images came back to Earth, one question arose. Is the James Webb Space Telescope, JWST, constantly discovering bizarre new objects? Every day, we delight in exploring the universe, mesmerized by the stunning lights of stars and planets floating through space and time. Not only does the JWST, located light-years away, allow us to see much further than our eyes can comprehend, but it has also revealed an unidentified object in one image. This particular picture, taken by the European Space Agency while observing the formation of two young stars around 1.47 light-years away from Earth, contained a tiny, enigmatic object. At the bottom of the picture, there is an orange mark that appears to be a question mark. While it seems small in the image, it is far from insignificant. In fact, it is enormous. The question mark shape was captured while observing young stars forming in vast rings of gas and dust. It is possible that this appearance is due to the two-dimensional perspective of the image. Right now, scientists have no idea what it is. Without further study, we may never know. Regardless, the finding has been confirmed by professionals, and it's possible that distant galaxies or structures are interacting in a way that creates the distinctive shape. The discovery highlights the continuous influx of new and unpredictable astronomical phenomena. Currently, scientists are focusing on a specific set of Earth-sized planets that could hold the key to finding life beyond our solar system. Despite the high likelihood of extraterrestrial life, no evidence has been found so far. However, one promising system, located exactly 40 light-years away, is the TRAPPIST system, which has 7 planets orbiting a nearby star. NASA's search for habitable planets goes beyond simply considering a planet's size and its distance from its star. A more effective approach is to examine the planet's atmosphere, as this can help determine whether it is habitable. The infrared Spitzer Space Telescope, part of NASA's exploration mission, discovered the 7 TRAPPIST exoplanets long ago. Now, the James Webb Space Telescope has measured the temperature of one of them, TRAPPIST-1b. Since its inception, the JWST has made significant advancements, and this is just the latest in a series of record-breaking discoveries. For the first time, a telescope has detected light from a tiny, cool exoplanet like those in the TRAPPIST system. These distant worlds, all about the size of Earth, exist within the habitable zone, where liquid water could potentially exist on their surfaces. However, the TRAPPIST planets are astonishingly far away, 235 trillion miles from Earth. They orbit a much smaller and redder star than our Sun, an M-dwarf star. These stars are more common in the Milky Way than Sun-like stars and are ideal targets for planet hunters. However, M-dwarfs are also more likely to erupt, emitting high-energy radiation that could damage newly forming extraterrestrial life or planetary atmospheres. When we focus on TRAPPIST-1b, we find that it is tidally locked to its star. One side always faces the star, while the other remains in perpetual darkness. This temperature difference creates extreme conditions. The day side reaches scorching temperatures sufficient to melt iron, while the dark side remains significantly cooler, though still warm enough to prevent methane formation. Despite these extreme conditions, atmospheric gases could influence the planet's capacity to host life. The ability to measure these conditions provides a unique perspective on faraway exoplanets and their atmospheres, bringing us closer to understanding the possibility of life beyond Earth. Scientists are now shifting their focus to understanding the atmospheres of these exoplanets in greater detail. By analyzing the light that passes through their atmospheres, astronomers can determine their chemical compositions. If key molecules such as oxygen, methane, or carbon dioxide are found in significant amounts, it could indicate the presence of biological activity. The James Webb Space Telescope has already demonstrated its ability to measure the atmospheric composition of distant worlds, an achievement that was once thought impossible. By using spectroscopy, JWST can break down light into its component wavelengths, revealing the unique signatures of various gases. This capability allows scientists to study exoplanets in unprecedented detail, providing crucial insights into their potential habitability. However, challenges remain. Many of the exoplanets being studied orbit M-dwarf stars, which are known for their frequent and intense solar flares. These flares can strip away atmospheres, making it difficult for life to take hold. Scientists are investigating whether these planets have strong magnetic fields that could protect them from such radiation. Despite these hurdles, the search for habitable worlds continues to accelerate. Future missions, such as the Habitable Worlds Observatory, aim to take direct images of exoplanets and analyze their atmospheres with even greater precision. These advancements bring us closer to answering one of humanity's most profound questions: are we alone in the universe? Meanwhile, the discovery of bizarre and unexplained objects, like the question mark in the JWST image, reminds us that space is filled with mysteries yet to be solved. Every new observation deepens our understanding of the cosmos, pushing the boundaries of what we thought was possible. As telescopes become more advanced and data analysis techniques improve, scientists are confident that the coming decades will bring even more astonishing discoveries. Whether it's detecting the first signs of extraterrestrial life or uncovering new cosmic phenomena, one thing is certain: the universe still has many secrets waiting to be revealed.